Wait, you like that story?
Yeah.
It's my pleasure to have Larry Scarpa here with us today. I'm trying to think if I should share what stories I can share about Larry. But just having walked around the studio trying to get people to come, incredible architect from Los Angeles, and in a lot of ways instrumental in thinking about a number of different things. I think his practice is transforming, but there's a couple of projects that I'm sure that my guess is he won't show, but I think are really important projects. And one is a dressing room that he did years ago for a small boutique where he wrapped shrink wrap that you would normally put on a boat, wrapped it around a frame. And so many people have followed that and thought about that project. And I think it's that care in thinking about making, the care in the way that things are built. The other project, which I know still is on your website, but is this incredible project that uses plaster lath. And there's a steel frame, and the lath is smooth on one side for the conference room, but kind of oozes out the backside. And so those two textures and that care for the way that something is made and the way that that produces a certain space is really incredible. And I guess the other story that I would share is Larry Larry teaches at USC currently. He's taught at Harvard, he taught at the University of Michigan, where I got to know him. And in the final review, or in one of the reviews that Larry's class was teaching, I ended up getting 6 stitches in my hand. And so that care for making and that thinking about getting students to consider materials and the way that they make things, that was a really beautiful folded Core 10 steel wall system that fell over during the review and got me out of the review early. So those 6 stitches that's how I remember.
I'm still
there.
with you.
But together at Brooks Scarpa, there's just an incredible array of awards, which I shared with you guys for the introduction. Over 100 design awards, National AIA Design Awards, Cooper Hewitt National Design Awards, record houses, record interiors, all of the biggest awards in the industry. I think Larry's got them. And so a lot of the conversations today, I'm looking forward to hearing about how the work is changing. The work is scaling up. There's schools, there's housing, there's institutional projects, but I think there's also opportunities for that care in the way that things are made, scaling up now to think about how those are done at larger scale. And so I'm really excited to have you here, and I'll just let you start. So welcome.
Thanks, man. So in the review, Carl sits down, and there's this 8-foot tall piece of metal, and he's looking at it, he touched it, and of course a student set it up and it started wobbling. And then it started to tip over, and Carl just reached over and grabbed it. And you could see it on his face. He was just holding it like still, but there was something going on you could see on his face. And then I looked over, and you could start seeing blood running out from the bottom of his hand. He goes, "I think I need to go to the hospital." Anyways, thank you for having me. I'm going to jump right in. This changed everything for architects. Prior to the Second World War, there were only 70,000 of these things worldwide. Before these were so popular, we used to build like this. This is the Monadnock building in Chicago. But if you look at like the plan, its shape is kind of dictated by its ability to perform passively. You know, you see it's got a big wide central space. It's very narrow so that you get natural light and cross ventilation. If you look in that hallway, There are windows above the doors so that air can flow through the building. And so they were designed differently. Once air conditioning became so widely used, we suddenly just became ignorant as architects. We just said, you know what, we got air conditioning, just do whatever, you know? And this building, the Seagram's building, beautiful building, but, you know, its plan has nothing to do with performance. If you compare those two, like just look at the lobby space between the two. There's not a single window in the Seagram's building. There's no natural light. Everything is artificial. So it's like, what do we really want to do? You know, what kind of spaces do we really want? So I, look around at other things. There are a lot of great examples of buildings that we can learn from, and this is one thing I want to talk to you a little bit about tonight, is about looking. This is the Phyllis Wheatley Elementary School in New Orleans, done in 1953 by Charles Colbert. And it's a beautiful building, but if you look at the plan, you know, it's almost exactly like the Monadnock. And it was that way for a reason, because it was designed without air conditioning. And, you know, it's this wonderful building with lots of natural light, cross ventilation, and really, really a beautiful building. And this building was around for the longest time until some smart person said, you know, it's a little warm inside here on days. We should just put air conditioning in and it'll be a lot better. Well, this is what it looks like now. So what happens is, you know, as soon as the building's not designed to be air conditioned. And so as soon as we feel a little bit uncomfortable, we want to throw things away. And this building will probably face the wrecking ball here very quickly. You know, another building also in New Orleans, done by the same architect about the same time, another school, is a brilliant design in New Orleans, raised up, created a shade porch. And if you look again at the plan, that two little lines in there is actually a stair, goes directly up. No circulation in the building at all. Glass cross ventilation both sides. It's just pretty magical. So point is, what I tend to do is when we start a project, I look at other things. And I'm showing you some of the things which were some of our research before we did a school in LA. And so we did this small charter school. It's a 500 student school in a very tough neighborhood in South LA. This school is built on a site that is 1/15 the size of a typical school of its size built on it. So it's basically an infill lot, but it has a lot of those things that I just talked to you about. If you see the plan, the long arm faces into the prevailing breezes, so it actually scoops the air between the building and induces airflow through that passageway in the middle. It's also south down below, so the building actually is shaped to shade the public space outside to the north. So this is kind of a diagram of it. It has 600 solar panels built into the south facade. And you can see the courtyard to the north. My staff actually put the shadow on the wrong side. We can build them, but we don't know how to draw them. The building, as you look at it, you can see the north side shaded. The west looks like it's solid. This is what the west facade really looks like. It's a very sculptural piece of the building, but it's just 2-inch steel fins, and they're spaced in a way that they provide like soft natural light into the building. And so you get classrooms which have views they have privacy, they have natural light. They rarely turn the lights on in these classrooms. And this building, because of its low usage of lighting and the solar panels, it produces about 80% of its own power. But, you know, I always look at these things too as like a architectural opportunity. You know, the idea that it can be both performative and aesthetic really has made it almost impossible for our clients to value engineer our projects. So like in this case, they're like, wow, the solar panels cost a lot of money to put on there. So I said, all right, well, you know, let's take them off and see what happens. Well, we took them off and reran our energy calcs with no shade on the south facade, and the mechanical system cost went up almost to the cost of the solar panels. So they said, oh, okay, you know, the client said, oh, now I get it. But for me, it's really, it could almost be anything. It could be perforated metal. I think, you know, what I've found is if you find ways to make buildings that are both performative and aesthetic, it's very easy to kind of retain your design intent amongst really tough budgets and other things that you're faced with. So on a different scale, this is a house in Venice, California, and it embodies a lot of those same things. If you look, the upper roof has solar panels, the lower roof has a green roof. All the rooms are single cross ventilation. You could see kind of the plan here. Every room is just one room deep, and it has either a courtyard or air can pass through both sides. So you can see, again, it's very close to the same principles that you would find in the Monadnock building or many other buildings from that period. This is how you enter. You come through a courtyard. This is their office space. And again, it cross-ventilates through that courtyard. And if you're in the office, you can actually see through the living space. So they can be in the office, watch their kids in the backyard. They can even, when they open the doors, yell to them from across the house. And then, you know, the whole building actually opens to the garden. You can see the green roof. And the bedrooms are small. We basically made the bedrooms really small on this so we could put most of it in the public space. All of them open out to this walkway. The parents' room is on the very end, so when the kids try and sneak out, they got to get by the parents there. But you could see start to see the solar panels emerge on there, the green roof. And then these are the bedrooms, again, all shaded, small, lots of light. You know, I always say to people, like, you know, who doesn't like natural light in here? Who hates fresh air? You know, it's just like common sense to do it. So we kind of do that on everything, even when our clients don't care about it. So there's the house, and we made it like a sort of big villa. It's a 2 stories, but we made it look like a big 1-story villa. And you could see the shade pattern on it, that all the openings are protected. I took this picture. This was their first trash pickup after almost 2.5 years. They couldn't get trash pickup because they had no power bill. This house is a net zero building. So in LA, for some reason, your trash pickup is tied to your utility bill, and they had a 0 power utility bill, so they couldn't get the city to pick up the trash. So they used the neighbors' cans for 2.5 years. This is their first official pickup from their house. So, you know, I call this really design-directed research. You know, we're architects, we're not really researchers like scientists are, but I think we should be doing more design-directed research. You know, I teach as well, and, you know, I know when I give an assignment, if I were to give an assignment for a wheel, you know, my students go get a rock and start carving or chiseling. You give that to a scientist, and they go look at every wheel that's ever been done or built by mankind as their point of departure. So I think we really need to be better researchers or look at other things and learn from what's out there, because there are so many examples of that. This is a project we're working on in Florida, in North Florida, at the University of North Florida in Jacksonville. And it's for an interfaith chapel on campus. That's our site right there. It's a great site. But I started to look at some buildings that were being built in Florida. This one's in Sarasota. This is a Lutheran church by Victor Lundy, and it was built in 1958. But again, if you look at the glass, look at the shade line on it. It's not just a beautiful building, but it's also quite performative. It has overhangs, so many things, and then like the space is just magical, you know. So this is what I wanted to do. I really wanted to just copy this building and put it on my site. So I started to look at then maybe other ways to kind of achieve something similar. So there's a system that was used on it. This is an industrial building from 1928. This is in Oregon. It's an armory building. But before we had big pieces of steel, this is how they would span large spaces with small pieces of wood. It's called lamella. It's basically like bringing the forces around with just small pieces of wood, and you get these big open spaces. So I began to think more about the possibilities of that. So we started to look at a way of using a lamella system, but shaping the building more that represents some ideas that I'll talk about in a minute. But as we do this, you know, we tend to look together. It's not just about what you see, it's about being there. So these diagrams, the one on the lower left is one about how you approach a building. In Florida, you know, it's hot, and it's like here in the summer, and humid, but on top of that, it's like really bright. So I also grew up down there, and I know what it's like to enter a building. You know, every building you just walk in, you freeze. Your eyes, the glare. So what we try to do is provide a sequence of how you approach the building. So it's got like big overhangs that shade you, that cool you off before you go in, let your eyes adjust. Then you go in, you need less air because you start to kind of transition into a comfort zone. The other idea we had was that in North America, the Polaris, or the North Star, is always 35 degrees to the north. It doesn't change. And so we started to make this big aperture that when you're in the chapel, that you could frame the North Star. It's hard to do a church for everybody. That's for nobody. So it's like to find these kind of things, these spiritual things. We kind of looked to more things, even, well, you'll see it here in a minute, how we placed the building on the site. So where we had not just the view to the North Star, but we also made the building that the summer solstice would go right through the building. So on one time a year, you could actually stand outside the building and see the sun setting through the building. And I couldn't get my mind off of this image, you know, the little chapel on the hill. And also these things which, you know, talk about formal dress, whether it's a priest or a wedding or something. So we try to make a building that was more like a gown, you know, or that could be for anyone. So that's our site, and then that's our building. So, and then this is how you approach it. The building kind of lifts up, and that's the shaded entry. as you'd see it from the lake. And then the interior with the skylight kind of above. We also just finished this building in Cedar City, Utah. It's a $50 million arts complex, and they've got these beautiful, red mountains there. And if you visit, the sandstone just from the weathering is just spectacular. So I started to think a bit about that sandstone formation. That's our site. And so we started to look at these things and how you might be able to transform a building that was a lot like the slot canyons that exist in the neighborhood. So we looked at ways really to have our building be kind of part of the environment that's there. So this part is the museum. It's 30,000 square feet. It's got a big canyon-like roof that there are no roof drains in it. They all drain to the two ends of the building, and all the water's collected in cisterns. But my client was very suspect that you're going to put no roof drains in the building. But we kind of worked through that geometry, how you can get all the slopes to flow. And part of it is really figuring out how to build it as well. So here it is on the site. And I'll show you a little clip of a bit of the construction of that so you kind of get the idea. So it's got the big porch that you're seeing in the front. One thing I really wanted to do was to have the artwork on the inside be able to be seen from the outside and not cover this is facing west, so it's a 110-foot cantilever that allows the gallery to have no shade devices on the windows, so that you can, from the street when you pass by, you can actually see the artwork inside the building. Another thing here I'll talk to you a little bit in about a minute is like, how do you actually make these forms, or how do you construct them as well? So here it is. You can see the big porch, the gallery, and it also has the whole gardens that go with it. But they use this porch here for outdoor performances and events and so forth. And it's really connects the campus to the city of Cedar City. And here you can see the panels in these canyons where the water comes down. So it all comes down there and either goes right into a big shaft that takes it to an underground tank, and then the overflow, if there is, just shoots right out of the crease or the canyon of the building. And it also, these are some of the gardens, and you can see the complex of buildings, old and new together. They have about 1 million people a year that visit this place now. It's the Shakespeare Festival. Another thing we've kind of been looking at is this idea of pattern making. And I don't think we really look at those opportunities enough. And I think there's great potential in architecture with pattern making. I mean, they do it with fashion. They make these custom dresses, and they're able to be repeated or altered in a way over and over again. So I kind of started to think more about how can pattern making be part of making architecture. And I look around, I look at other things. So that's on the left, a market in Mexico City. And I took that picture on the right in the Orlando airport, all the cheesy tourist attractions there. But in either image, if you look at them, the individual component is really simple or even ugly, but when they're put together, they're really beautiful. So I started to think, how can you take a component that is really simple, that's really easy to make, and put it together in a way that you're creating art? So I looked at other things, and I found these ladies down in southwest Alabama, down in Gee's Bend. They've now become quite famous. I would buy these quilts from them, you know, big quilt for like $100, $150. Now like a little one like this is $2,000. But they have no training at all in design. But they make these incredible, incredible quilts. They're just like magical, you know, and I always say to myself, how can I do that? How can I be that good and that free and that loose? It's like as soon as we start making a building, we tend to get all bunched up and stiff, you know, so I'm always looking for ways to let things unfold more organically. So we did a little project down in Florida, a small project, and I said, let's try to be like those ladies at Gee's Bend. And so we wrote this kind of script. This is called the Gateway Sculpture. And we kind of came up with these components, and we said, let's just have the components randomize themselves and form. We'll do the pieces and let them make their own pattern. So all we would do would move the columns around or change a shape, and then everything would then repack itself in place. And so that's what we did. That's what we built. So it all then became standardized components. We broke them down into these standardized pieces, and we sent it all out. It was fabricated in Denver, Colorado, and shipped in pieces and put in place in like 2 weeks. And it was done very affordably as well. So here you can see them making some of the components, packing them up, arriving on the site, and then there it is in place. And so I got this job. We were new. We opened a new office in there, and they were building a new city hall, and they wanted like a gateway sculpture there. And I was the only one that said, I'll do it and have it done in 3 months. I guaranteed it would be in place in 3 months. So part of what you'll learn to do too is if you're successful, you create your own work. So here's some other shots of it. So similar with the building, this is an office building we did in Monterrey, Mexico, where it's a very large combination of office and factory. And the mountains there are spectacular, but we want to do something with lighting or clear story on the roofs. So we kind of would figure out a system of rationalizing the roof geometry, and then looking at the panelization of the building, like how do you, again, standardize panels on a form which is really very unique. And so we went through that whole exercise and then worked with a fabricator in Monterrey, Mexico to develop the system. That's the other thing too, is we tend to work closely with people that make the buildings, because oftentimes they know a lot more than we do. And then here it is. And this is west facing. So at night, the light kind of returns to the outside. But again, you can see in the daytime that it's shaded. You have north facing clear stories that allow light into the office. That's the north face with all glazed, open to this rain garden. And you can see the office space up here and the entry that is on the western side of the building. So I've looked more and more at this idea or notion of patterns to try and develop a strategy. The projects I showed you were really more like, almost like an artist, you know, where we would just do them in a less rigorous, standardized way. So I started to think, can we do it more in a way where we can do one thing? And so I found these images. This is a flight path or takeoff and landing. It's basically the same coordinates given to an airplane when they take off left or right. But what's so beautiful about that drawing is not the path itself, but the variation on the same set of coordinates. So like if you have a single description, how can you modify it in a way that it becomes that beautiful? And so I started to look at ideas to do that. And early on, it was like this. We would take this is a 52-unit housing project for mentally disabled people, and we took the screens that again provide shade, they provide some sense of privacy, but they're all the same custom water jet cut panel, and we stacked them 10 deep before we water jet cut them. So we paid one price for 10 laser cuts. And the bottom one was a bit rustic. If you've ever done it, it like gets very rough when it goes through deep stuff. But you know, then we just powder coated them different colors so that you get kind of this variety, but they're all exactly the same component. So we did kind of custom things on affordable housing, which is unheard of, but it was very economical to do. Then we got commissioned to remodel a Frank Gehry building in Santa Monica, the Santa Monica Place parking garages. And it's miles of facade, right? And the city wanted to redo it. They didn't like it. They wanted to be a better city building. So I said, how can we do a facade within this small budget we have and really do something nice? So we came up with this panelized system. We designed 2 panels. The purple piece that you see is actually a random board that we just got a bunch of random materials and asked the contractor to just insert them. It didn't matter what went in there, just put whatever. And that's a difficult concept for people who build things because they like it to be exactly what you tell them because they think you're going to make them redo it because it's not what you said. So it was publicly bid, so we organized these panels in a pattern so that we could get kind of that variety and being able to do it over 2 very big garages for like almost 3,000 cars. So the contractor, the winning contractor, they actually prefab these things by the 1 panel by 40 feet long. So they actually did them bigger than we imagined. And the whole thing went up like within 2.5 weeks. So here you can see we also put some retail on the ground floor. But we gave the building a whole new skin to make it really a better city building. And you can see it here in its place in the city. We also redid the street, the whole thing. It was a fairly big project with the facade being just a component of it. So I'm always looking at things like this, you know, the little via airmail stamp. It's nothing really, but the kind of just shift that it's not aligned is really intriguing to me. And I'd like say, how can I create, it's the same exact stamp. How can you do that and still make it beautiful without it being monotonous or boring? So we got commissioned to do a housing project in Santa Monica, and I started to think about this idea of like 1 single unit. That's it for the whole building. And I found this artist named Patrick Hughes, and he did these paintings that he calls Prospectivity. And what he does is it looks like the paintings are moving, but it's actually the shape of the canvas. And as the viewer moves by them, it appears that the thing is moving. And if you notice too in there, if you look at his work, he actually uses very famous artwork in the paintings that he does. And it's the whole idea of movement is really fascinating because it's not the painting that moves, it's you that's moving that's basically making the painting move. So that's what I wanted to do. And so I went to a local company. It's actually a big national company called C.R. Lawrence, who does a lot of things in our architectural products. And I asked them if they would be willing to work with me to design a shutter. And so we designed this custom shutter, and we spent a lot of time doing it, and then we put the one shutter on the entire building. And so it's really a stucco box. It's got a 4-foot porch, and then the shutters are put outside the porch. So we did all of the drawings, the fabrication drawings for this. I just wanted to show you some of them. These are actually the drawings of which they fabricated from, which we created all of these, all the details with them. And you'll see some other projects where we're doing this now more and more, but down to the very screw. And why we do that is because when you'll find out when you have an idea and you show it to a contractor, they look at it and they go, ooh, that's going to be expensive. And so your idea, even though it may not be expensive, you know, they give a price and the client goes, we can't spend that money. But if it's quantifiable like this, they can give you an exact price. And then you know what it's going to cost. So what happens is there are beautiful views to the east and west. And you want glass because the views are great. But it's on a busy road, you know, and it's east and west. So the sun just pours in, so you want to be able to protect that. So the shutter gives the occupant the opportunity, if, you know, they want to be private, they close it. If they want sun in, they open it. If they don't care that people see them walking around in their underwear, they leave it open. You know, those that do, close it. So in a sense, the building gets redesigned every day. So this is really the first one where I think we were able to just take a single module and do an entire building with that single module. This is now one we're working on right now in downtown Los Angeles. It's the Flower Mart, and we're redoing the Flower Mart, but we're adding 325 units of housing. So now it's like huge scale. And like this is where the contractors count every penny. And so we have this idea for doing the balconies in a strategy which is really the same amount. I'm not going to talk to you specifically about that because I have some other ones to show you. I just want to show you some views of that. So where that's kind of led me to is this idea of like mass customization. Well, that's what we call it. Is, you know, how can you do things on a bigger scale? How can you do a design that you want to do and retain that kind of hand craft that Carl talked about that I did early in my career? I still want to maintain that, but how do you do that on public bid projects? How do you do it without getting sued for malpractice and all those other things? So I started to look more about that, and this is Carl and some of the older people here may remember the spirograph. Any of you heard of a spirograph? You know, when I was a kid, this was a toy we had. That was a drawing I did with the spirograph. You know, you just put a pen in and you move the gears around, right? It's like, that's like phenomenal, you know, like a 10-year-old kid, and it's just lines, but it's like, it's spectacular. I can't believe I even did it. You know, and like pickup sticks, it's like, they're just like, you know, they're just a stick, but when you throw them out, it's like, it's mesmerizing, you know, it's to see them the way they lay out. So I started to think about like the power of a line. And so we started to look at this idea of taking lines and applying it to an idea called ruled surface geometry, where you can put a series of lines together and you can build these really complex shapes by just using a single line. So we did this competition and I had this in mind, And we made all these like beautiful renderings of these sweeping facades and everything. This is it here. And we actually won the competition. So this was a design build competition, and I had teamed with a contractor, guaranteed maximum price, you know, with the design. And part of the reason I think why we won was because we were actually delivering a real design in their price. So now the contractor was freaking out because we won. We have to build it. And he's like, you better know what you're doing. And I didn't know what I was doing. It was just an idea, you know, we were not supposed to win. So, but it's a very simple concept. This is the idea. You have a top chord and a bottom chord. And if the top chord and bottom chord are the same length, you can connect them with the straight line. It's super simple. So in theory, that should work magically. So now we started going crazy. I'm like, man, this is going to be the best thing ever. You know, look at what we can do. You know, so we just started making drawings like this, and we came up with this whole system. This is like what typically would be done, and you know, this is what we're going to do, all right? And so we started to look at this, and what we failed to take into account is that the building is like 75 feet tall, and you can't span from the top to the bottom with just two chords. You need intermediate chords. And those intermediate chords throw the whole ruled surface geometry out the window. You know, it just doesn't work because you can't rationalize those points in between. So now we had kind of a new problem. And this building was, it was permitted with foundations, then concrete, and so we were basically designing it as we were building it under a guaranteed price delivery. So we were like working like crazy to figure out how we're going to do this. And so we started to look at a lot of conditions where you get torsion then, and twisting became an issue. So we started to like look at how we could rationalize the surfaces and the curves by implementing other things. So we wrote our own scripts to do this, and we started testing these. We did have an engineer, but the engineer's like, hey, can you give me your scripts, you know? So we did all this work testing them. Now, in a perfect world, those blue things that are curving like that, that's like really bad. That means every single piece is unique. So if it were perfect, it would be like a flat line, and that means every piece would be the same. But there were so many things that we had to look at. So like, what's the optimal span of the horizontal supports? What's the optimal thickness of the material, the shape of the material? So it was a giant, complicated puzzle that, you know, was changing every day as we would build it. So I'm just kind of showing you some of our analysis, and this is close to the very end, and you can see that that graph is getting almost flat, and we got it to only a handful. There were 8,500 pieces, and only a handful of them were unique in the end. So, you know, then we would kind of look at our model. We would take all these beautiful rendered curves and go, uh-oh, you know. So we would go piece by piece around the building, take these areas, and then rationalize those curves. So all of the curving components were broken down into only 2 or 3 radius on the entire project. And so we provided all the fabrication drawings for this project. So they went from our desk directly to the sub to bend them. So you know, this is how it would come out on the site from our drawings. That's how it would go up. And they just went away with the horizontal supports. So the skin, you know, in the competition, this is what I was thinking it would be. We would just go to the store, we'd find a, you know, standard shape, and we would buy them and just put them up. Well, that didn't work either. There were, again, too many complexities to make that work. So I found this thing called pen board, which had properties that were much closer to what we needed, but ultimately it didn't work. So we started to design our own extrusion. So we started to look at a similar shape, you know, that conceptually matched what I wanted in the design competition, but that would meet all the paradigms of torsion, of you know, its ability to span, and was the most efficient weight. So what I'm showing you is how this shape transformed as we modified it, and that was our final shape. So we invested, it was like $28,000 for a mold, and we produced miles of this stuff. So here it is. Here they are testing it to make sure that the properties actually turn out as planned. And then there's our happy contractor over there with the 8,000 plus pieces packaged up and ready to go. So it was a sigh of relief for him. And then they put it in place. So all the horizontal supports had a little weld that was computer put on where they're to screw it. And you had 4 guys and 2 cherry pickers, and they put the whole facade up in a week. And so the building too, all these actually change. They're not in the same orientation. So they lean and straighten around the whole building. So they're not vertical, but they're also not the same shape, but they're basically 8,000 of the same exact form. And here's the space off the main pedestrian stairway or circulation down to the plaza. And then that space where you actually come from the parking into the plaza. And from the subterranean parking area looking up to the plaza area. And then some other views from the street. And then there's our happy client in the end. So, you know, we also look at this. I call it a little bit of calculated risk-taking. We don't throw caution to the wind and do whatever, but we have what we think we can make work, and we kind of test it and go with it. And I think it produces a lot better results than if you know exactly what you're going to do. This is another example, you know, just a stack of books that, you know, just, I don't know, when I look at it, I don't know about you, but it's hard to take my eyes off it. You know, it's like mesmerizing. And so we got a commission to do a house in Chicago. And I was like, that's great. I can do it. I can do this out of brick. And my client wanted a metal house. And I was like, it took me a long time to convince him to do brick. So when we did, we started drawing brick. So here's like one of our drawings of an idea for the brick facade. We drew every single brick. Oops, that's my son, sorry.
Yeah, baby. Yeah, baby.
Sorry about that. Call him later. And then here again are some of these testings or studies of like brick. And again, I wanted to do the same thing like Patrick Hughes. I wanted to be Patrick Hughes. I wanted to make my buildings move. And also because when I grew up, when I was a student, people actually did moving buildings that all failed. None of them work. So I knew that it's really hard to make a building move, but could I make a building perceived to move? And so the whole idea, I wanted to do this brick building that was in motion. And so a lot of these studies are about that. So you can see the drawings. This is, again, a drawing of every single brick of the facade. And then we test it with like modeling. So here's a piece of a model. And like you can't just really have a picture because a static picture doesn't show it. So we would make these little films. So if you see here, the facade goes from solid to void. It changes as the user moves by it. it's actually changing from solid to void. And the owner's actually moving in this house in about a week, but he's been spending a lot of time there lately. And he says now people come by and they stop their car in front of the house, and then they back up, and then they pull forward, and they back up, and they're like trying to look through the brick, but it keeps changing on them, you know. So I thought that was great. The other thing too is, you know, the brick, like this is Chicago, and like if you look at this building, like you notice the brick in the front and on the side are different. Like all the good brick is always on the front, and then the garbage brick is on the side where you don't see it. So I'm like, we're gonna use the garbage brick. They call it Chicago Common brick now. So here it is in construction. And the same thing when, you know, the mason looked at this, he goes, oh my God, how am I gonna do it? You know, when he saw like a model, but then we showed him, you know, an actual diagram of how to do it. And he's like, oh, that's really simple. And he got super excited about doing it. So here it is in construction. These are just 1x tubes horizontally. There's no vertical support to it. They just help in the lateral direction. So here you can see it. And then that's Robert. And what also helps is the light comes through it from the back. So as the sun moves around, it actually enhances that moving as well. So I'm just going to show you some different shots. This is just what comes from it. It's not modified in any way, shape, or form. And there it is in the snow. We have another building. This is a 26-story high-rise building, again, trying to adopt that same idea. You know, this is typical. Well, in housing, the plans of a unit, you know, we learned is make them all the same, and you stack them, and you get like a whole lot of efficiency. What you could have a lot of latitude with is the perimeter of the building, so like the balconies. And so like you see these odd shapes on the balconies. But we just took a typical concrete slab building. And we basically form them differently. There's a repeating pattern of forming on each floor so that formwork can be reused around the perimeters. And those are shaped to then connected vertically to form the balcony. So you get this really dynamic building, which is nothing more than just tilted edges of concrete. So it's our costs. Again, our owner was very fearful of when looking at the costs of this, and then when the costs come in, they're like shocked that it's not more expensive than it is. The last thing I'm going to show you is a project we're doing in Florida. About 2.5 years ago, we opened an office in Florida, and we've been working on what I think are some really important issues that's happening not just there, but around coastal areas around the country. This is Fort Lauderdale, and this is not after a rain. This is what's referred to as sunny day flooding. So what's happening in coastal areas of Florida now, and in Fort Lauderdale, it's really bad. The storm drains are actually delivering water to the downtown, and it's flooding it when the tide rises. So on a perfect, beautiful, sunny day, this is what's happening. The streets are flooding. And so they're doing all kinds of things like they're putting check valves on the storm drains, okay, but now there's water in the drains and mosquitoes are breeding in them. So it's a big problem, and you can look at what's happened. The number of floods that are happening now are growing exponentially. So the problem is getting worse and worse. So we were hired by the city of Fort Lauderdale to develop a long-term resiliency plan for them of how their city can deal with the sunny day flooding and sea level rise over time, over the next 50 to 100 years. So this is the basic problem that occurs. So you have rain, right? It rains a lot in Florida, so you get attacked from the sky. Okay, the sea level's rising, so you're getting attacked from the ocean, right? And the groundwater now is raising, so it's coming from all sides. It's like impossible to really stop it. So we've done this modeling throughout the city showing what different stages of conditions would happen at so many feet. So we've been working with the city to establish what rise do we want to design to. And we're basically now looking at the city as if they're going to have 3 feet of sea level rise in their city. So we've done this kind of mapping around the city, and I'm just showing you this. Fort Lauderdale's really bad. Everyone thinks Miami is the worst spot, but Miami's actually on a little high piece of ground. Florida's like a sponge that's leaning to the south. And if you look at the historic maps, the water comes right through Fort Lauderdale to the east and to Naples to the west, and Miami's like a little hump that's pretty dry. So this is Fort Lauderdale area with 3 feet of sea level rise. What it would look like if they got 3 feet. It's pretty much all underwater. So we've developed these kind of toolkits to deal with it, and they're kind of incremental. We have kind of 3 adaptation toolkits. So we call them adaptation strategies because there's sort of no turning back, so you just have to adapt to it. So the first one is this kind of really simple strategy where you're kind of dealing with conditions that you're localizing the flooding. And then there are other ways where reintroduction of kind of landscapes that help with this whole issue. So kinds of plants that can take the salinity of the water, and also other plants that have high levels of evapotranspiration, like oak tree, scrub oak in Florida can evapotranspirate one tree like 600 gallons per hour. So it's pretty amazing what you can do. So these are, I'm just showing you some of the toolkits which we're developing, and the end product is going to be a book that the city will use to show other private developers and people, here's what they should be doing with their, when they develop buildings. So these are the kind of stages from stage 1, 2, 3, and 4, which you just fortify, then you retreat, and then you abandon, and you rebuild. So, we've done these mappings all over the city, looking at areas of how to deal with it and what it might look like. We won a national AIA award with this project this year. So here's the defensive, the first thing that you would do. This is over the next 20 years. So this is the way to do it over 20 years. And then the following 30 years is begin to kind of retreat in the more, it's a strategic retreat in areas and let the water kind of come up. And then these are then adjusting as the water rises. So the buildings, everyone thinks buildings are permanent, but they're really tied to a mortgage cycle. So pretty much there are very few buildings that last more than 30 years. They tear them down or alter them. So, it seems like a catastrophic thing, but if you even look at, you could take Detroit and look at the history of what's happened to Detroit over time. Buildings come and go, so it's not as dramatic as one would think. These again are some of our, I'm just showing you some of our toolbox strategies that that we're developing. So, you know, you remember the hurricanes last year, right, that hit South Florida? So we were in the middle of working on this. And the city of Fort Lauderdale, they just spent $4 million doing a beach renourishment program. So because they're losing sand, so they can't even get the sand out of the ocean anymore. So they go to Central Florida and they truck it over and they put it on the beach to make their beaches bigger. So they just spent those millions of dollars, right? The hurricane hit, and this is a picture I took like days after the hurricane. So the road's gone, completely gone. So, you know, it's coming. We just have to do things about this. It's something that's going to be with us. It's going to be your generation. And the good news is there's going to be lots of work for you. The bad news is you need to do something about it, okay? So I'm putting that seed in your head. You know, so, you know, the thing is there are people doing good or like looking at things and planning for it, but it's not been embraced wholeheartedly. But you find things like this. This is at the back of my office. It's a Santa Monica museum. You know, they roll that solar panel out every day, you know, like with the cones and everything around it. I have no idea what it does, but it's doing something, you know, and you find this everywhere. They're delivering refrigerated vaccines on a solar camel, okay? So you can find this stuff everywhere, but where we really need to make bigger strides is on an institutional level. Like the building we're sitting in, you know, is going to be owned in perpetuity by the university. There's no reason this shouldn't see a new life as a really sustainable building. So I'm going to leave you with something that one of our great architectural historians wrote more than 50 years ago, Lewis Mumford, and he wrote about architecture and civilization. So he said, quote, "Our architectural development is bound up with the course of our civilization. To the extent that we permit our institutions and organizations to function blindly, as our bed is made, so must we lie on it. The future of our civilization depends upon our ability to select and control our heritage from the past, to alter our present attitudes and habits, and to project fresh forms into which our energies may be freely poured." Thank you very much. I can take some questions if you have questions. Okay. You don't have to ask them. Okay. Yell it out so they can hear you.
So when you were doing that, when you were doing the the urban planning in Fort Lauderdale, was that largely schematic, or I saw a lot of diagrams, but I didn't see a lot of like technical drawings. But I noticed that you had like it all contoured out and.
Yeah, I mean, we have a team of engineering consultants, scientists. We have a huge technical team, but the whole point of what we're doing is like many people have made books that have everything you need to know, but nobody can read them or figure out what to do. So our book is basically like a graphic manual that shows like common people, like this is what you do. And we have a whole, you know, we have the multi-volumes of scientific data and all that kind of behind it. So that's really what we're doing, is doing that as the work. And what I'm showing you is how that work is being presented.
Okay, so they're gonna probably integrate this in with their master plan.
Excuse me?
the city will integrate this in with their master plan?
Yeah, part of what they do is they have to constantly tell people and go code, enforce it, and do all of that because people don't understand it. So now they'll have something that they can give out that can be understood, and that's going to basically become their guide for their master plan.
Any other question? James, you mind?
I have a question. So this may be a pragmatic question. You talked about your Chicago client who had the desire to have a metal building, and you convinced them to do a brick building. Having hired a number of architects to do residential projects for myself, I know. Are they there? I'm curious about how that conversation shifted to such a radical change in material.
Well, he saw our work, and he had seen some of our houses, and he just said, I want that house. That's what I want in Chicago. And, that's great, but it's like sometimes, I remember there was this artist, he's a ceramic artist named Tony Smith, a British guy, does beautiful work, and he tells this story about, he made work and he became famous over the work. So then he did a show at a gallery, a new show, and he did a different kind of work. And the gallery owner invited all the people, lined them all up to buy the work that he was doing before. And when they showed up and it was not that work, they all left, So you can get, artistically, I think you can get to a point where you begin to plagiarize yourself. And I think it's important to have kind of a freshness. And I really had never done a brick building. And it was something I basically had a conversation with him too. Is like I pleaded with him to do a brick building. And the end of the day, if he insisted on metal, I would have done a metal building. But, it was a conversation, and I find if you have the conversations, that you can get to an understanding. It's not that I demanded that he do it or say, I'm not going to do it if you don't do brick. But it seemed to me like, you could do something that was original, that was interesting, that was of the place, and kind of, I think it should be. I didn't think you should take a California building and just drop it in Chicago. I hope that explains it.
Thanks for the lecture. I really, nice to see you. I really enjoyed the clarity of process, but also the energy of the experimentation that you're laying out across all of the projects. I wonder if you could speak a little bit to the way things work in the office and how that spirit of experimentation. The way
things what?
Work in the office, how you're structuring the office and the teams that you form around the different projects and how those two things work together.
Did you ever see a little kid's soccer team play? That's our office. We're all like huddled around the ball. We're like 20 people, so we're not a huge office, but in the recent years, when people visit our office, like architect friends, and I show them what we're doing, they're like, how are you doing all that work with only 20 people? And it's become like a repeated question. So I started to question it myself, like, how are we doing that work? And the truth is, I would say 95% of the projects we're doing with other architects. So they're team projects. And in fact, some of them are, like I'm doing a project with Lorcan O'Herlihy, we're both considered design firms. So we would be 50 people if we were doing all the work. So I think that today's world, you the team practices how it only works that way. And also, I don't try to pretend that I know everything. So when we work all around the country and around the world, there are other people who know how to do it better than where we are, or where we go. Like in Utah, we had a local firm that we work with. Chicago, same thing. North Carolina, same thing. So we find they become really creative partnerships. We don't get an executive architect that just executes. We find someone who's going to be involved in the design early, and we're going to be part of the construction and the construction document teams at the end. There's no split. We have a matrix of responsibility where everyone's involved across the entire process. And so we just have, our teams are pretty efficient because we're doing like big projects with actually pretty small teams within our office. And then a lot of our teams actually share some of the projects. So it's interesting when we do the bigger work, you know, it's like people are assigned a project, but they help on other projects when they need like a boost or more, you know, people power on them.
Yeah, I'm in the interior architecture program, and I found the two different styles of projects that you had. You had a project that seemed to be more problem solving with the Florida water problem, and then just projects that seemed to pose a question: can we do this, or like what kind of problem are we solving? What kind of, like, between the two projects, two kinds of projects, what do you find the most enjoyable with the practice that you guys do?
My partner often complains, says, can't we just do the same thing twice? You know, it's not the best business model, but, you know, I've tried really, it's hard in today's world. Like, people want to, if you do housing, you're a housing architect. If you do single family homes, you can't do housing or museum. If you do a museum, you can't do a house. It's like everyone wants to kind of pigeonhole you, and we do everything. Like, if you look at our work, it spans from single family homes to office buildings, affordable housing, museums. We kind of reach all the spectrum. So I'm interested in not doing the same thing over and over and over. It's really strange. I have a good friend who recently passed away. He was the first or second architect in Santa Monica, and he's done every project, you know, hospital, car dealership, house, school. And I would say to him, Jim, how do you do like all that work, you know? And he goes, I just had my name on the door and they come in, you know? And today it's a world of specialization. So when we pursue a project, like we ultimately didn't win the project, but I got called by the Philadelphia Zoo to do, you know, $135 million expansion to their zoo. I've never done a zoo before. And I said to them when they called, I said, I think you have the wrong person. And they said, no, you know, but they had other people like me because they found that if they just got the same zoo people, they would get the same solution. And they wanted people to think, you know, a bit differently. So when you do different project types, actually I try to convince my clients when they say, well, you've only done 3 schools. You know, and I said, you know, if we did hundreds of them, it would be passed to the lowest person on my staff for them to work with you. You know, because I've only done 3, you're going to get me on your school, and I'm going to be super excited about it. And that works sometimes, and it doesn't work sometimes, you know.
Thank you. I've got a follow-up. Thanks for your lecture. Are there certain
types of projects or maybe criteria that would lead your firm to decline work, to say no?
Yeah, I mean, we do. We do say no to, you know, a fair amount of work, but it's not, you know, it has to do with a lot of things. I mean, timing. I mean, I wouldn't say it's because, I mean, we do projects like the affordable housing projects have a fixed budget, not a penny more. They have a fixed schedule, not a day more. You know, they got a client who, the ones we work with care, but they don't understand the building as like an art. So like when the contractors shoot nails into exposed concrete wall and they take it off, they go, well, it looks okay. You know, so it's not the easiest sector to work in, but we do it, but sometimes I say no, you know, and mainly, you know, if the people come to us for the wrong reasons, you know, so there's no set budget. We also do pro bono work for people, so it's not always the same criteria. It's a case by case thing.
One more question? Anyone? Sure.
So early on you talked about light and natural ventilation, and a lot of the houses that you showed were in warmer climates. So how could you take the rules and everything that you've learned about like natural ventilation and light and apply those to houses in like around Michigan in colder climates?
Yeah, it's you know, they clearly are different, but when I was doing all that stuff in California, and the people in Florida would say, well, that's California, but how do you do it in Florida? And now I'm doing it in Florida, you know, so now it's different everywhere. You can't build really without mechanical systems, but you could build smarter. You can do things better. Like a lot of the homes are very, you know, well-to-do people with big budgets and, you know, multi-million-dollar homes. And we, you know, talk to them about their lifestyle, you know, in a way like, okay, we can put, you know, 30 or 40 tons of air conditioning in your building, and you can guarantee in the hottest summer day, you will be nice and cool, you know, but we could do less, and there might be 4 or 5 days of the year where you're not so comfortable. You know, is that something you can live with? If it is, we can save $50,000. We can take out a whole bunch of room, get more head height in your building. You know, they're like trade-offs. So it's like we don't, again, just do it all alone. It becomes a discussion point with a lot of these things are, you know, we've become accustomed to, you know, having everything our way, you know, and so, you know, if you do that, you just keep going as is. But it's like my own house, and I've done, you know, these big houses the same way, where they'll spend millions of dollars on a house, and the whole house is not air conditioned. You know, the places are air conditioned, and we have relief valves into other spaces. So you can do it. It's just like I've heard from people in Florida when the hurricane hit down there, the power was out. So everyone opened their windows. And I was saying, yeah, once it's open and you get used to it, it's not that bad. You know, and that's the way we used to live. We just don't live that way anymore. So, you know, you would definitely do something different in a cold climate.
Okay, thank you so much.
Thank you.
Dean asked me to remind everyone that our AIAS is having their annual auction on the 3rd floor. You might check out some of the things that